Alright, class, this is my retake, second time trying this one. I'm on some new software, and apparently my videos cannot be longer than 14 minutes and 30 seconds. So, here we go. We're going to try this. Alright, so we're moving on from understanding all of these different types of figures, and we're focusing in on segments and angles. Now, when we talk about segments, right? We know now the hat for a segment, but if we ever write it without the hat, what we're actually talking about is the length of that segment, or the distance between the endpoints, okay? So please note, this is huge. This, right, hat, it means you're talking about the figure itself, the actual segment. If you write it without the hat, you're talking about the distance. Very kind of subtle difference, but it's big, it's huge, okay? So please kind of try to wrap your head around that. Now, we can also have points between points. And really, that just means that the points must be on the same line or segment. And we already know that. This is called collinear. All right. If a point's going to be between A and C, right? So like if I have A and I have C, well then B can't just be anywhere. It has to be directly on the same line. Or in this case, it's actually a segment, excuse me. Okay, so something like this. That's big. That's huge. We'll use that too. And now we're actually kind of jumping ahead. We know that the distance between endpoint to B and then the distance between B to the other endpoint, well, that should total the entire segment. All right? And so we're going to rewrite that again because it's so important right down here. If B is between A and C, well then AB plus BC must equal the full AC. All right? So to make this a little better, and I'm not going to make you redraw this, but I'm going to kind of try to highlight some things. All right, if I'm talking AB, well then I'm talking about this little part right there. And if I'm talking BC, well then I'm talking this bigger part right there. But if I'm talking AC, well I'm actually talking about the entire piece, right? Or the whole. And that's what I want you guys to think about. Segment addition is really part plus part equals whole. Okay, part plus part equals whole. Okay. Now, same types of things work for angles. However, we kind of have to talk about angles a little bit more first. So I'm going to start by drawing an angle. Boom, boom, boom. Maybe I want to call my angle ABC. That's good. Well, points that are in the interior of an angle are the points that are between, or that lie between the sides of an angle. All right? So something like X or Y. Exterior of an angle is really just the set of all points outside the angle. All right? So as I make my pink star, maybe I'm talking about Z, which is outside of my angle. Hopefully we see the difference here. Inside, outside, inside, outside, inside, outside. Okay? Measure of an angle. We are going to be using degrees exclusively in this class. Maybe in some higher level math classes you might learn some things about radians, but that is for another day. And we need to know that 1 degree is 1/360th of a circle. Where's that 360 coming from? Well, that's coming from the fact that a circle has 360 degrees in it. Okay? Okay. I said it was coming back, and here it is. Angle addition is extremely similar to segment addition. And this idea of part plus part equals whole is coming right back. So to help us understand that, let's draw our picture. I wish this software had a running clock. I have no idea what time I'm at. Oh, geez. Okay, here we go. So we know our angle is PQR. PQR. R. Hopefully you're all good with that. We know that Q must be the vertex, and then it doesn't really matter where the P and the R go, but Q must be the vertex. Well, it's also saying that S is in the interior, so I'm going to draw a ray through S. And now, hopefully you guys recognize, by me drawing that ray, I just created two angles. I have a part, another part, and together they must equal the whole. So, right here, my part, PQS, and we have to be really careful because now we're not talking about the figures themselves, we're talking about the measure. And so in math, when we're talking angle measure, we have to use this fancy little m. So the measure of angle, PQS, and we're talking about this angle right here, so that is measure of angle, well, let's see here, SQR, and in total, they have to equal the whole thing, right? I didn't want to make that too dark, but part plus part equals the whole, so the measure of PQR. Okay? So again, what do I want you to take away? Part plus part equals whole. As we flip onto the next page, I don't think I'm going to spend a ton of time on the top because I feel like you guys usually come in understanding this already. So I'm going to give you some numbers, and then if we have to talk about it, we can. Acute angles are our tiny angles, or smaller angles. They are less than 90 degrees, so they have to be greater than 0, but they also must be less than 90. Right angles are our nice ones. I feel like most people love right angles. We know that those are exactly 90. Obtuse, those are the ones that look bigger than right angles, so they have to be greater than 90 but less than 180. And then straight angles. Straight angles are actually exactly 180 degrees, and I want you to understand that straight angles you've already been creating. All right? What am I doing right now? What did I just create? Oop. Well, prior to this video, we thought that this was just a line, right? We made one ray. We made another ray going in the exact opposite direction. So we really created opposite rays. But now I want you to know that you didn't just create a line. You also created a straight angle. Because I know that from this ray all the way to my other is 180 degrees. All right? Okay, we're getting there. Oh man, I have no idea on time. I hope it's going okay. All right. So now we're going to kind of work on drawing some pictures and writing equations. This is something that is very important, and we're going to spend time just doing this. So if I know B is between A and C, well then I know that I'm drawing, oh, I probably shouldn't have put that in there yet. I know I'm drawing a segment, and I know I have 3 points, and I know that A and C must be the endpoints, because B must be between. So something like that. Once you have your picture, it says to use segment or angle addition to write an equation. So I would say part plus other part equals the whole. Hopefully we're seeing that. This is a part, this is another part, and this is my whole. I could do the same thing with an angle. Make sure you're very careful labeling. In this situation, B must be the vertex, and then it doesn't really matter where the endpoints go. But I do know that S must be in the interior, so when I draw in S, it has to be between those two sides. Now, again, when I drew that third ray, I just created 2 parts, right? I now kind of have this CBS, so maybe I'll say the measure of angle CBS, and then I have this other part, SBA, so the measure of SBA, and together these 2 parts must equal the whole, which we said was CBA, or ABC, doesn't matter. Okay? Once again, what was this? Part, and whole. Okay. Last little section. In this section, some of you guys may be perfect at already and have done this, but I still want to go over it. Measuring angles. Okay? Now, my protractor is old and it's kind of, I don't know, tough to see, and it's big, it's clunky. You guys might have a nicer one. But for me, like, do you see how the ray doesn't extend? So what I'm going to do is I'm going to extend my rays. And while I'm at it, I'm going to do these other ones as well, because I know I'm going to need to. But now I know that I need to measure the distance from this side, not distance, excuse me, the degrees from this side to my other side. So, I center my protractor, I line it up as best I can, and I have a problem, because I don't know if I'm supposed to use my inner numbers or my outer numbers. I am here to tell you that you always use the track, or the numbers, where the 0 is. So do you guys notice how I go 10, 20, 30, 40, 50, or 170, 160, 150, 140? Well, my 0 would be on the inner track, right? It would be 0, 10, 20, 30, 40, 50. So that means because my 0 is here on the inner, I'm using my inner numbers. So 55. I'm going to say that this is 55 degrees, which is acute. Another important kind of way to think about this is, like, you can say it's one or the other, either 55 or 125. Does that look like a 125 degree angle? Absolutely not. Okay, so it can't be larger than 90. When we move on to our next angle, is similar. Okay, it doesn't line up perfectly, but it'll work. And again, 0 would be in the inside track, so I use my inside numbers, or 110, 115. And I know that this is obtuse. Again, just to kind of show you what I'm talking about with, like, process of elimination, if I used the upper number, it would be 65. This is not 65 degrees, so don't say 65. Okay, last part, trying to go quick here. If I'm trying to draw an angle, you always want to start by drawing your vertex, and I'm going to call that letter E, because I know for a fact that E must be my vertex. Now, you want to extend a ray. Doesn't really matter the direction, but extend a ray. Maybe make a point that we'll label in a little bit. And now we know that we want to go 55 degrees. So I line up my protractor along that ray. And I know that because I'm starting at 0 right here, I'm using my inner numbers. So 55 would be about right here. Now, you don't need to extend all the way to this point, but you know once it's lined up that if you create a line, or a ray, it's going to be going in the correct direction. And now I can create my other point, and the last thing you have to do is label the letters. I had a G and an O, so G, E, O. Okay, so there you have it. There is 1.2 talking about segment and angle addition. All right. I will see you next time. Later.